Hello everyone. Today we are going to learn relationship between phase and line voltage per delta connected load. Delta connected load. So what is the relationship actually? So we have to prove VL is equals to V phase and IL is equals to root 3 I phase. So in star connection, we had a neutral, whereas in delta connection, we will not have any neutral. So I'll just draw the figure. There are three phases, R, one more is this, Y, and another is E. Looks like delta. So these are the three phases. This is R, this is Y, and this is B. Now I'll just write currents. This is your IR, this is your IY, and this is your IB. So IR is equals to IY is equals to IP. That is equals to line current. Next, I will write voltages. For that, let me change the color for the convenience. So from R to Y, voltage will be VRY. From Y to B, voltage will be VYB. And from B to R, voltage will be VBR. There is no neutral here. Let me write VRY is equals to VYB is equals to VBR is equal to line voltage. And if you see from R to Y, what is phase voltage? VRY. From Y to B, it would be VYB. From B to R, this is your R, this is your Y, and this is your B. So R to Y, VRY, Y to B, VYB, and B to R, it would be VBR. So VRY is equals to VYB is equals to VBR is equals to V phase. Whereas, what are line currents now? Line currents will be IRY, IYB, IBR. So from R to Y, IRY. From Y to B, IYB. From B to R, it would be I. Simple sequence. After R, Y. After Y, B. Again after Y, B. After B, R. Like that. That sequence need to follow. So just write IRY is equals to IYB is equals to IBR. That is equals to I phase. So if you see from observation, what I can see that VRY is equals to VYB is equals to VBR is equals to line voltage. And phase voltage is also same. So I'll write is equal to V phase. So I can say VL is equals to V phase. Next, what I should do? I should prove. I have to prove IL is equal to root 3 I phase. This I need to prove. This is second condition. To prove. So how will you prove? For that, I'll take any two phases. For that, I'll take any two phases. Let me just quickly write. So these are the two phases. This is your R and this is your Y. This is your B. In the R line, IR. In next, from R to Y current is IRY. Next, from B to R current is IPR. Now what you do? Apply Kirchhoff's current law KCL at node R. What does Kirchhoff's current law state? Sum of the currents entering the junction equal to leaving the currents. IR and IBR are entering, whereas IRY is leaving. So from here I can write IR is equal to IRY minus IBR. This is your first equation. Now if I take another two phases, I'll get more equations. So after R, it is Y. After R, it is Y. After Y, it's B minus I B, after B, R, after R, Y. Again, if you take one more, two nodes, you'll get after Y, B, after Y, B, after B, R, minus I, Y, B. This is your third equation. Now, I got all the three equations. What I'll do, I'll just draw the phasor. So, as you know, all the three phases will be 120 degrees apart. Correct? So, this is I, R, Y. If you remember, in star connection, here instead of I, we do VRY, VYB, VBR, because we were proving voltages. Here, what we are proving? We are proving current. So, this is your phasor diagram. This is your phasor diagram. So, this is your IYB, and this is your IBR. Then what is the opposite side? Opposite side would be minus IRY. Then here opposite side would be minus IYB. Here opposite side would be minus IBR. I hope this is clear. Now if you see the equation, first equation, what is it? IR is equal to IRY minus IBR. IRY minus IBR is giving us what? It's giving us IR. Again, same concept. O, A, B, C is a rhombus. For example, O, okay. This is A, this is B, and this is C. O, A, B, C is a rhombus. Is a rhombus. And also, OB is perpendicular to AC. Correct? And also, let me name this as M. So, can I say OM plus MB is equal to OB? Why OM plus MB is equal to O? As they are the diagonals are the perpendicular bisectors in rhombus, I can say OB is equal to OB is equals to OM plus OM. Why? Because MB is also equal to OM. So I'll get OB is equals to 2OM. Now if you see OMA triangle, OMA in triangle OMA, it's a right angle triangle, no? So one angle would be 90, one angle will be 60, and one angle will be 30. So total is 180. So I'll apply sine 60. So what is the formula for sine? Opposite by hypotenuse. So sine 60 is equal to OM by OA. Sine 60 is equals to angle OAM equal to 60. You should remember whenever you have an angle, so on angle A, I have 60 degrees. So that is why I've written angle A in between. So sine 60 is equals to what you are getting? OM by OA. What is OM now? OM is cross multiply. Sine 60 into OA. So what you will get? Sine 60 is root 3 by 2 OA. This is your equation 2. Substitute equation 2 in equation 1. What you will get? OB is equal to 2 times of OM. So I can say 2 into what is OM? Root 3 by 2 OA. 2 gets cancelled. You will get OB is equal to root 3 OA. So if you see in the figure, what is OB? OB is IR. No? OB is IR. OB is IR. IR is equals to root 3. What is OA? You see in the figure, what is OA? OA is IRY. Correct? No? OA is IRY. So I can say line current is equal to root 3 times of phase current. Hence, we have proved it. So in star, what were we doing? In star, what you were proving, we are proving IL is equal to I phase and VL is equals to root 3 V phase. And in delta, it would be opposite of that. So in delta, you'll get IL is equal to root 3 I phase and VL is equal to V phase. So that's all. Thank you.